What if there were invisible parking spots in space that could make or break humanity's future among the stars? Imagine launching a multi-billion-dollar telescope only to watch it slowly spiral away or crash into oblivion because you missed one of these hidden cosmic sweet spots. These aren't just science fiction, they're real, and they're called Lagrange points. A Lagrange point is a special position in space near two massive objects, like Earth and the Sun. At these precise locations, the gravitational pulls from both bodies and the motion of a satellite balance out perfectly, allowing a spacecraft to almost park in place with hardly any fuel. According to scientists, a satellite placed at a Lagrange point will tend to stay in place. These points are so stable and energy efficient that they've become prized locations for some of the most ambitious missions in history. The James Webb Space Telescope, for example, orbits the so-called L2 point, about 1.5 million kilometers from Earth. From there, it can keep its solar panels pointed at the sun and its mirrors open to the darkest parts of space, all while staying in touch with engineers back home. But here's the catch. If we ignore these natural parking spots, we risk wasting billions on failed missions, or missing out on discoveries that could change our understanding of the universe. Harnessing these invisible anchors could be the difference between a new golden age of exploration or catastrophic setbacks.
Let's rewind. What exactly are Lagrange points, and why do they exist?
To answer that, let's break down the science behind these mysterious points and discover how they reshape our journey through space. Imagine a cosmic chess match between the Earth and the Sun, where the winners can unlock the secrets of our universe, but the losers risk squandering billions and falling behind in space exploration. Hidden within this contest are mysterious zones known as Lagrange points, places in space where the game changes for anyone aiming to explore the cosmos. Miss these points, and you risk burning fuel, losing missions, and letting other nations leap ahead. Lagrange points are not just theoretical curiosities. They are 5 real strategic positions created by the gravitational tug-of-war between the Earth and the Sun. These spots, labeled L1 through L5, act as cosmic parking spaces, where satellites and observatories can almost effortlessly hitch a ride alongside our planet as it orbits the Sun. Why are these points a big deal? At each Lagrange point, the gravitational pull from the Earth and the Sun perfectly balances with the orbital motion of a smaller object, like a satellite or a telescope. This means that a spacecraft placed at one of these points appears motionless relative to the Earth and the Sun, moving in perfect sync with their celestial dance. As one expert put it, the interaction of the forces creates a point at which some smaller body will appear to be parked in space relative to the larger objects. The physics powering these points is surprisingly elegant and potentially game-changing for space missions. Instead of burning through precious fuel to maintain position, satellites at Lagrange points require almost no energy to stay put. Some, like L4 and L5, are so stable that a satellite could remain there for decades without costly course corrections. This saves not only fuel, but also money, making ambitious long-term missions more feasible than ever. The science behind these points dates back to the 18th century, when mathematician Joseph-Louis Lagrange first described them in a groundbreaking paper published in 1772. His insights revealed that, in any two-body system, whether it's the Earth and the Sun, the Earth and the Moon, or even Jupiter and its moons, there are exactly 5 spots where these gravitational balances exist. So why should you care about these hidden cosmic parking spots? For space agencies, scientists, and taxpayers, understanding and using Lagrange points can mean the difference between historic discoveries and costly failures. Place a telescope or a probe in the wrong orbit, and we risk wasting years of work, millions of dollars, and missing out on breakthrough science that could transform how we understand the universe. The stakes are nothing less than the future of exploration itself. But these points are more than just equations on paper. What actually happens when we put them to use? Let's look at how Lagrange points revolutionized a mission you might have heard of, the James Webb Space Telescope. Its journey to one of these gravity sweet spots changed the game for astronomy. Imagine losing $1 billion telescope because you parked it in the wrong cosmic spot. This is the razor's edge on which the James Webb Space Telescope balances, thanks to Lagrange point number 2, its stable home nearly 1.5 million kilometers from Earth. Before you tune out, know this. The stakes are not just numbers on paper. Missions, money, and decades of research hang in the balance. A Lagrange point is not empty nothingness. It is a rare equilibrium where gravity and motion cancel out, creating a pocket of stability in the endless push and pull of space. At these points, a spacecraft can park and orbit with barely any fuel, needing only the tiniest course corrections to stay on station. As one scientist described it, if a satellite or space telescope is placed at a Lagrange point, it will maintain a fairly steady orbit and need very little rocket boost to stay put. That efficiency is not just convenient, it is mission-defining. Every extra kilogram of fuel burned in space means less room for instruments, shorter missions, and more risk of failure. Some Lagrange points, like number 4 and number 5, are so stable that spacecraft may not need any boosts at all. Imagine launching a satellite and almost never having to worry about it drifting away. This is not a theoretical bonus. It is a game changer that decides whether ambitious missions live or die. For the James Webb, NASA's choice of Lagrange point 2 unlocked 3 mission-saving advantages. First, Webb stays close enough to Earth for fast and reliable communication. Second, its solar panels always face the sun, guaranteeing continuous power for sensitive instruments. Third, Webb enjoys an uninterrupted, deep view of the cosmos, shielded from Earth's shadow and stray light, critical for capturing the faintest signals from the edge of the universe. But do not mistake these benefits for minor perks. The difference between picking the right and wrong Lagrange point is the difference between triumph and disaster. The true cost? Billions of dollars in hardware, once-in-a-generation scientific opportunities, and years, if not decades, of human effort. One miscalculation could doom a mission before it even starts, wiping out hope for answers to the biggest questions in astronomy. This is why Lagrange points are not just clever physics trivia. They are indispensable tools for space exploration. Space agencies worldwide design entire missions around them. Ignoring these cosmic sweet spots means fighting against the universe itself, wasting fuel, and increasing the risk of failure. But by harnessing them, we can push deeper into space, smarter, safer, and more efficiently than ever before. But if Lagrange points are so useful, how exactly do we find and use them in practice? Let's break down the real mechanics behind these cosmic parking spots. What would happen if we turned Lagrange points into bustling cosmic hubs? Or if we simply left them empty and unused? Right now, Lagrange points are like pre-built parking spots in space, waiting for us to claim them. The James Webb Space Telescope is already at one of these spots, orbiting a stable Lagrange point about 1.5 million kilometers from Earth. Because these spots require little to no fuel to maintain position, they are perfect for long-term missions and high-value equipment. Imagine the possibilities if we built on this foundation. Lagrange points could become the crossroads for space industry, hosting giant platforms for satellite servicing, fuel depots, or even factories manufacturing materials in zero gravity. They could act as staging grounds for missions to the Moon, Mars, or beyond, helping humanity leap further into the solar system while slashing the cost and risk of space travel. But the stakes are much bigger than just industry. If we overlook these strategic locations, we risk missing out on crucial opportunities for planetary defense. Lagrange points could be ideal places to spot and intercept incoming asteroids before they threaten Earth. Many stars in a galaxy orbit in stable positions called Lagrange points, showing us that nature itself uses these cosmic sweet spots for stability. So why wouldn't we? There is also a climate dimension to consider. Scientists from Exeter University say the world needs to focus on finding positive tipping points, moments when small changes trigger big, lasting benefits. Just as breakthroughs in renewable power and transport have already started shifting the climate game, using Lagrange points for global monitoring could provide early warnings for extreme weather or even help coordinate climate interventions on a planetary scale. On the other hand, neglecting these points could mean losing out on all these breakthroughs. The infrastructure we choose to build, or not, at Lagrange points could shape the next century of science, security, and sustainability. It is a classic crossroads moment. The choice we make today could decide whether we gain an edge in the new space economy or fall behind as others seize the advantage. So, what does this cosmic opportunity mean for you, and how can everyday people help shape the future of space and Earth together? Let's look at what you, whether space enthusiast, student, or innovator, can actually do to be part of this unfolding story. What if you could spot hidden advantages before anyone else and avoid losing ground to competitors? Lagrange points unlock this superpower, serving as a blueprint for finding stable, low-effort opportunities, not just in space, but in every field where stakes are high. Just like a satellite needs only a tiny nudge to stay in place at a Lagrange point, smart design means using natural balances to cut costs and energy waste. If engineers miss these equilibrium zones, they risk over-engineering, burning through budgets, or falling short on performance, whether building bridges, writing code, or launching spacecraft. For investors and innovators, the lesson is urgent. Lagrange points reveal the outsized impact of finding the sweet spot, the exact moment where a small action sparks massive, lasting change. Miss this, and you might lose out on the next big breakthrough. Seize it, and you can ride a wave of transformation, as seen with clean energy tipping points reshaping global industries. In education, Lagrange points train students to seek stable solutions where interests clash, a skill vital to solving real-world challenges. Ignoring this mindset could leave future leaders struggling with costly mistakes and missed opportunities, both in classrooms and boardrooms. For the endlessly curious, the stakes are clear. The universe hides patterns that separate those who lead from those who lag behind. Failing to spot these patterns means wasted resources, overlooked discoveries, and falling behind in the race for tomorrow's breakthroughs. So, where do you go from here if you want to harness the power of cosmic balance? Let's break down exactly how Lagrange points work and why they're the backbone of humanity's most daring space missions. The universe is not just chaos. It hides leverage points waiting to be used. Lagrange points are proof that even in the vast, swirling cosmos, there is structure and opportunity. These 5 special locations in systems like Earth and the Sun are not random. They are precise positions where gravity and motion balance perfectly, creating natural parking spots in space. That is why the James Webb Space Telescope orbits at the second Lagrange point, about 1.5 million kilometers from Earth. There, it saves enormous amounts of fuel, enjoys an ideal view of deep space, and maintains a steady line of communication with our planet. Without this sweet spot, missions would burn through resources or even fail to hold their place. This idea goes beyond astronomy. Just as scientists use Lagrange points to unlock the secrets of the universe, we can look for hidden leverage points in our biggest challenges on Earth. Climate experts, for example, talk about positive tipping points, moments where small, targeted actions trigger big, lasting change. Spotting and using these moments, whether in science or society, can turn stagnation into transformation. So, the next time you hear about a breakthrough, whether in space or in solving problems closer to home, ask yourself, what leverage point made it possible? Where is the hidden balance that could change everything? Understanding leverage in space invites us to seek hidden balances in every system we face, from technology to society.